The observable universe occupies an area of about 90 billion light-years. It can be assumed that the part of the universe that we cannot observe will be much larger. Space is so large that the human mind is simply unable to comprehend it, at least for now. However, according to some theories, it may turn out that the cosmos is much smaller than it seems to us. How can this be? Welcome to Cana. Let me take you across the bridge connecting the macro and micro world. According to modern data, the part of the universe that is not yet observable may be about 20 trillion light-years in diameter. Just imagine. Based on the data that we have, we can assume that most of outer space must be empty. Post-or part of space that has been explored is quite small. When looking into space, we will see gigantic vast expanses of icy emptiness. But what if the universe fits into one atom? Sounds absurd. Don't rush to include skepticism in this theory. It is more like philosophical fiction. It may be not so incredible, but for beginning, remember what you know about matter. Any matter consists of the smallest particles of atoms. These little ones are the basis on which the universe is based in, the usual sense of the word for us. Atoms are so small that even with the most powerful optical devices we actually cannot see them. Interesting fact. In essence, we cannot even know with sufficient certainty what exactly an atom looks like. We can only assume this going from Titiya. Despite the fact that we cannot see atoms with our own eyes, it is considered proven, and the fact that the atoms themselves consist of smaller subatomic particles, such as neutrons, protons, electrons, and quarks in our time. It is already known for certain that atoms are so numerous and small that the body of an average adult consists of approximately 87 atoms. Let us remind you, this figure can be represented as a 7 with 27 zeros. Just imagine this quantity, but an atom in turn also has its own structure and complex structure, namely, it allows you to think about the incredible theory of micros. What does an atom look like, so to speak, from the inside from a school chemistry course? You probably remember that an atom consists of a nucleus which is formed from protons and neutrons and electrons moving around it. This model, proposed by Ernest Rutherford in 1911, was called the planetary model of the atom. Really, the analogy suggests itself because the movement of atoms around the nucleus is very similar to the movement of planets around the sun. Moreover, this model was never refutation, with the remark that the movement of electrons should be described by the laws of quantum mechanics and not classical particles, which are the basis of matter, have a similar structure with not a little solar system. Could this be a simple coincidence due to the laws of physics, or is there something more in this similarity? Much more fantastic. We will return to this question later. But for now, try to answer the question, how many electrons are in our universe? Sounds absurd. Isn't it true that such a number cannot be processed? Even the most powerful computer, not to mention human brain. But what if I tell you that there is only one electron? Exactly. Such hypothesis, called the theory of one electron universe, was put forward by American physicist Richard Feynman, and it sounds like pure fantasy. According to it, there is only one electron in the world which moves in space and time so quickly that it seems to us as if there are a great many of them. Just one particle gives shape to everything that we consider the whole universe as such. Of course, this theory did not find many supporters, but the funniest thing is that, thanks to the principle of the identity of electrons, it is impossible to experimentally distinguish one electron from another. It cannot be refuted. Such a paradox, but let's go back to the structure of the atom and the incredible theories that it gives birth to. Let's try answer the question, what is the size of an object, despite the everyday habitual meaning of this word? In fact, the concept of size is quite mysterious, and relatively, for example, the world around us is adjusted to our size because we built it. But with the creations of nature, everything is far from so simple. Mountains for us, huge planets are gigantic, so much so that it is impossible to comprehend. But ants and all microorganisms of life, from simply small to microscopic. But do ants consider themselves small? Do they understand that they live in a world of giants? It is unlikely that their world is familiar to them in the same way as our world is to us in comparison with space objects. We are not even microscopic. the master of horror and fantasy. Howard Phillips. Lovecraft, in his works, promoted the idea of the insignificance of humanity in the face of the endless space, and here we are, approaching the question of our video. What if our universe can fit on the tip of a needle? Suddenly the solar system is just an atom, one of myriads in some other matter starting from this version. It is logical to assume that in those atoms, and particles of which our existence consists, there can also be concluded worlds of pores, really not weeks. It turns out that so our reality really can be on subatomic worlds and so on ad infinitum in the direction of decreasing and increasing scales. Sounds incredible, but exploring the incredible is our job. The most interesting thing is that looking at the universe known to us, POB, not fun. We easily accept the same conclusion. The sun begins with the smallest particles like an atom and ends with colossal celestial bodies and entire star clusters. Everything from your today's lunch to some recently discovered exoplanet consists of the same building material. The dream of the scientific world-finding theory of the whole world is the most important building block in the work on this theory. Having tried on quantum mechanics and classical physics, generations of young scientists may be able to understand the true nature of our universe and even that which goes beyond it. In the end, even according to one of the most popular versions of the origin of our universe, it began as an infinitely dense and small singularity. Then from this small point it spread to all known limits. This is called the Big Bang theory, from small to something very big. It also seems to you that this is quite consistent with what weddled you today about the micro and macrocosm. Yes, but there is also an important remark. Point is not equal to the atom singularity that gave rise to the Big Bang, despite its small size, contained everything necessary to build the entire universe, and to call this origin from one atom. It is still impossible. There is still the so-called string theory, an excellent candidate as a theory of everything. The general idea of this incredibly complex theory, which has many interpretations, is that the atom is not that spherical object, whose shape and appearance we remember from school, but rather strings or something very similar to them. The relationship between these vibrating strings includes almost everything known to science, the laws of classical physics, including gravity, as well as quantum mechanics. But string theory also has weak points. Explaining a lot, it starts to stumble, for example, on dark matter, in the case of which string theory begins to sag, but there is no need. Pessimism. Scientists have been struggling for a long time to attach the doctrine of dark matter to the theory of Ström. At the end of 2018, Swedish scientists published a new version, according to which our universe exists on the border of a constantly expanding bubble. This version rejects the 4 dimensions familiar to us, 3 spatial and 1 temporal, and suggests that we consider our entire universe to be only vibrations on the surface of this bubble. What happens inside the bubble, or at a distance from it, remains a mystery. How do you like such pectia point in a small piece of reality located on the surface of a bubble, which itself in turn can be part of something much bigger? Perhaps our whole world is just a proton or a quark, just a small part of reality. Why don't we feel it at all? Does the atom that is part of your sunglasses feel that it is just an atom that makes up plastic? A definite answer to this question. In the end, we should only be grateful that our common huge house called the universe is full of such amazing secrets. The universe is an amazing place filled with inexplicable phenomena and epic events. The most amazing of them are gamma bursts. They are accompanied by monstrous energy emissions occurring as a result of explosions. Fortunately, such phenomena are observed in galaxies extremely distant from the Earth. If the situation were different, the solar system and humanity along with it would hardly have a chance of survival. What are gamma bursts, and what are they as a rule? Gamma bursts are divided into short and long-lasting, from a millisecond to an hour, and more deadly. But even from afar, the impressive phenomenon is a relatively narrow beam, flying in opposite directions almost at the speed of light. It appears at the moment of a supernova explosion and marks the magical moment of the birth of a neutron star or a black hole. This is not the only scenario. Sometimes gamma bursts also occur during the merger of neutron stars. But what the SF Space Observatory recorded goes beyond the classical explanations and is even slightly frightening. Today we will talk about the giant JB ring consisting of 9 gamma-ray bursts, which is one of the largest known structures in the universe. Gamma-ray bursts as a phenomenon were first talked about on July 2, 1967. The fact is that American space satellites of the Vela system recorded a strange flash that could not have been atmospheric or space phenomena, and even more so nuclear tests. Such a discovery was a complete surprise. Therefore, probabilistic models for explaining the origin of gamma-ray bursts have been proposed hundreds, and more than 5,000 scientific papers have been published on this topic. By the way, how is it possible to detect a gamma-ray burst using a method called spectroscopy? Electromagnetic spectrum covers electromagnetic waves with different frequencies. In this video, we are interested in the hardest related to ionizing radiation, within which gamma rays can be detected. Gamma rays after the detection of the first gamma-ray burst registered under number GARB 6772. Many other discoveries occurred of this kind. These were short, long, close, yes, consequences of monstrous explosions in deep space. At first, scientists were at a loss as to what could have generated such intense emissions. Another question is where these emissions could come from. First, a theory was proposed saying that these are echoes of events occurring not just anywhere, but directly in our galaxy. But when the study of gamma bursts rose to a new level, it became clear that these are phenomena of the entire universe, and are usually located much further than the boundaries of the Milky Way. Meanwhile, the list of gamma bursts continued to be replenished. But what was discovered in July 2015 by a group of Hungarian-American astronomers shocked the scientific community. The discovery was preceded by the following: in different time periods were systematized data received from several observatories of the world, and on the basis of the specified information, SD conclusions about the discovery of a certain structure located incredibly far from what was discovered by scientists. A giant ring of gamma bursts stretching 4.6 billion light-years is considered the largest object in the universe, located in the list the most after the Great Wall, Hercules' northern crown. The remoteness of the mysterious structure from the Earth is also impressive, more than 9 billion years visually. If you observe it from the surface of the planet, the ring formed by 9 gamma explosions is 70 times greater than the diameter of the full moon. In the sky, it is noteworthy that all the point bursts are at the same distance from the Earth. The question arises, what is this giant structure, and what is its origin? Pine some assumptions. Titan's a peculiar projection of simultaneously occurring explosions. Rather, they alternately detonics that the specified phenomenon is extremely rare, and the chance that such structure could have formed at all is 1k dsya. And yet what is a tone of the assumption says that we are dealing with a giant supercluster of galaxies surrounding a monstrous clot of dark matter. But the boldest hypotheses are the following. Some astronomers observing the object mentally try to further increase the found structure, and without that, not small adherents of the mentioned theory, they assure that we only observe the inner disk, but externally it reaches a diameter of 10 to 12 billion light-years. If this is true, then the giant JB ring can safely claim to be the largest universal structure. But cosmological theory claims that such conglomerates are impossible due to the isotropy of the universe, which does not allow random fluctuations. In fact, this also means the unreality of the existence of colossal galactic walls discovered by astronomers in the past years. What conclusion can be drawn from this? Either the cosmological theory somehow incorrectly interprets the realities of the universe, or supersruk, so accurately outlined by 9 gamma-ray bursts, exists. Only the imagination of astrophysicists. How dangerous such things can be impulses to at least slightly imagine the scale of the energy emissions received from gamma bursts. It is necessary to compare them with something familiar. For example, the sun. If we assume that light will explode one day like a thermonuclear bomb, then the energy that will be released will be equivalent to a one-time burst, and not even the strongest. Such an explosion at a distance of light-years from the Earth would be deadly for us only. Imagine in a matter of seconds of energy bursts that it can be compared to the explosion of an atomic bomb on every hectare of sky, and we assure you the atmosphere will not help Earthlings, the armed forces of life on the planet. There will be extermination. Even if the explosion occurs at a distance 100 times greater than the specified all the same, the consequences for the Earth and its inhabitants will be very sad, respectively. Each gamma explosion is capable of exterminating all life within a radius of thousands of light years. Fortunately, a phenomenon relatively rare, but considering the extinction of dinosaurs, it is possible that it happened. Noticeable damage to the Earth's biosphere is periodically inflicted at least once every 100 million years, by the way. Some gamma-ray bursts can be seen with the naked eye, despite the fact that they are billions of light years away from the solar system. But let's get back to an identified circular structure discovered in the depths of space. They are wondering what to do about candidates for the culprits of gamma-ray burst were holes, comets, giant stars, and even cosmic brains. But now astronomers seem to have determined and narrowed the location in the observable area of such a huge conglomerate. Therefore, astronomers' assumptions are more like fortune-telling on coffee grounds. Perhaps new, more advanced observatories will soon appear that will be able to look even further into the cosmic darkness to detect and pull out all the skeletons of this universal closet. Man is the highest stage of evolution, the most intellectually advanced species living on Earth. Knowledge is a fundamental need, sapiens. Thanks to intellect, curiosity, man has made life more comfortable, subjugated other species, and confidently swung at the cosmic distances. And although the car ceased to be the limit of dreams and the computer from the library science fiction department moved into every home, still, there are areas in which we are absolute children, and one of these areas is teleportation of objects at a distance is one of the favorite topics of science fiction writers who, as is known, are always ahead of their time and inspire scientists and inventors about teleportation. Alfred Bester Tal Klein, Stephen King wrote, "But if in science fiction works teleportation is described in parts across, then in the real world everything is far from so rosy. Developments in this area have been underway for a long time, but there are very few significant results so far. Can't the plots of science fiction novels come true? Or will teleportation remain on their page? Can this convenient but extremely risky way of moving become a progressive breakthrough or a curse for humanity? Let's try to figure it out." Teleportation, the term itself, originates from Latin and consists of the words carry and far. If you describe the process in simple words, then it involves the instantaneous movement of an object to any point in the universe. The term was coined by the American writer and researcher Charles Fort. It is worth noting that the concept implies several types of teleportation, including the most popular in the 20th century. Quantum and quantum teleportation was seriously discussed in 1993, after the publication of an article describing this phenomenon, naturally, about lightning-fast movement of a person from one point. In another, there was no talk. No, we are immeasurably far from this. Experiments were carried out exclusively with elementary particles. And despite the seeming magic, this has nothing to do with magic. To understand the essence of the process, you need to accept as an axiom the fact that all objects are a set of information algorithms. A person is also no exception. Therefore, teleportation means, first of all, transferring information from one to another. In the case of photons, it looks something like this. The sender has a particle in a certain quantum state that he wants to transmit to the addressee using an exact description. At this stage, the emphasis is on accuracy and not on speed. But if there is a theoretical basis, can't this mean that teleportation soon has a chance to become a reality for us for the first time, mathematically proved that such a thing is possible? It is true that it is possible to apply calculations in practice at that time. No one thought about it indirectly. Other inexplicable phenomena were discovered, for example, black holes, the existence of which has not been experimentally proven to this day. What happened later was strikingly different from the scripts of Hollywood films, where another Arnold Schwarzenegger was dashingly transferred to the planet Mars using teleportation water. To this day. But so far, it has been possible to transfer, not the material object itself, but information about its quantum state. And this is already a great scientific achievement, because theoretically, information manual is enough to successfully restore the original object in a new place. By the way, the process of teleportation is familiar to us in everyday life because it can be compared with fax. The sender sends, not the document itself. Electronic information, addressal, so receives an exact copy of the required paper. And yet the difference between fax and teleportation is significant. In the second case, the original object is completely destroyed, reviving in a completely different location. What is the quantum world, and is it different from the usual one? Yes, and a very bright example are particles. In superposition, judge for yourself. In reality, a person cannot be alive, and MTV at the same time. Reality forces the object to choose a single state but not, such as quantum reality. Particles in it, like Schrödinger's cat, can simultaneously take both states while no one is watching them. In other words, there is a kind of superposition of one on the other. This is what the Dean paradox. In a closed box in which theoretically at any moment a device can work launching poisonous gas into the box. And while the box is not a pen, predict the state pers impossible. The gas trap can work by chance, and the probability of this outcome is exactly 50%. Thus, for the observer, the cat in the box is both alive and dead at the same time. To realize this is quite difficult and not surprising. Delhi, the greatest minds of the world, could not fully assimilate this brain-crusher information. But this is exactly how quantum physics is arranged, and the best minds of humanity will have to figure it out for a long time. How can quantum teleportation work? For its full implementation, it is necessary to meet the conditions of mutual entanglement of two. A state connection allows particles to read each other's state even at enormous distances. When discussing this amazing issue, Einstein's common phrase, "God does not play dice," is often mentioned. What do the dice have to do with it? They are directly related to the subject of scientific debate because, turning to the analogy, it is easier to understand the essence of the phenomenon entanglement. Imagine the dice. If you throw one of them, it will show a 2. Then the player will definitely know what is the value of the second cube, even without seeing it. A similar situation, and with entangled quantum particles. Why does the universe complicate everything so much that can you do ease of being for us initially? Nobody promised this phenomenon is difficult to comprehend, but this does not mean that the mentioned principles ops in this direction began decades ago. Their initiator was a professor at the University of Vienna. Anton Zeiger experiment started in the Canary Islands in a laboratory on the island of Palma. Created a pair of photons. One of them was subsequently sent to neighboring Tenerife, located 150 km, traveled literally riding a laser beam to the photon superposition, joined the third particle candidate for teleportation, after which photon C interacts with particle A, staying photon by NRI well, and then the matter of technology by turns into an exact copy of SAISI, that is, teleportation happened if we discard scientific in detail. It turns out that the information about the original got to another location where, with due skill, it is possible to restore an identical sample. But how can all this help in the main question of possible teleportation of a person? Will we be able to travel without resorting to the help of starships and other devices theoretically? Yes, but in practice everything is not so simple. What is needed to implement the process? Firstly, teleportation cabins located in different places as well as an entangled pair located in them separately. In the third cabin there must be an object to be moved, or, if you like, cloning. The computer compares its state with the entangled particles and sends information to the teleportation point, where a copy of the object is created. Of course, smoothly only on paper. Think about it, the EU count will erase the information incorrectly then, instead of you in teleportation potato, and chances to return to the previous. The state simply does not exist because the original material is destroyed. You will say, is the computer capable of error? Who knows? Because in our body, there are approximately more windows of atoms than if you add neural connections to this number, connecting them in the correct order. It becomes clear that at the current stage of technology development, similar refers to outright phantasmagoria. But if in the foreseeable future, there will be supercomputers capable of processing monstrous amounts of information, it is possible that humanity will make another progressive leap, actively observing it with the help of telescopes, painfully wondering whether there is life on these celestial bodies. And with the development of quantum teleportation, the problem will automatically disappear. People will be able not only to study the planets personally, but even organize tourist trips to them. Can teleportation bring humanity closer to a first-level civilization? Yes, but there is one unpleasant nuance. Even if everything works out as expected, a preserved person signs of a unique personality. By the way, a similar problem also manifests itself. Before scientists are trying to develop a scheme for loading the human brain into a supercomputer or on another electronic medium. Perhaps with the help of teleportation, it will be possible to move only inanimate objects and not living beings, because until now, no one knows what exactly makes each person a unique personality. In answer, psychologists of the future, since the ethical side of teleportation is much more difficult to solve than the technical one. And while physicists are pondering about increasing the distance between teleportation interstellar voyages and the problems of preserving personality, we know this will definitely happen. Subscribe to the channel, like and suggest fresh ideas for traveling at light speeds. Bring the future closer together.